Segev, really appreciate you joining our session today here at Carey Business School. Delighted to welcome you. Segev is a senior technical staff member and technical leader at IBM Research, specializing in optimization, game theory, and ML. Segev has over 20 years experience in applied advanced analytics, AI, optimization techniques across a bunch of domains, including automated diagnosis and logistics, and helps IBM and its clients make better decisions. He currently focuses on developing algorithms and tools to integrate LLMs with optimization methods for business decision-making, and addresses multi-party decision-making use cases through a blend of game theory and ML. Segev holds an academic record in OR, computer science and AI, has contributed to over 35 publications, and has around 30 patent submissions. He is a 3-time Informs Wagner Prize finalist and was a finalist for the 2018 Informs Innovative Application Analytics Award. Segev earned his PhD in Information Systems Engineering and has an MSc and a BA in Computer Science from the Technion. He also serves as a research associate in the Faculty of Decisions and Data Science at the Technion. Segev, really appreciate you coming in today, and really looking forward to your talk. Over to you.
Okay, thanks very much. Can you see my slides, the full screen?
Yes.
Okay, it's a great pleasure to be here. Thanks for the kind introduction. Just a question, how long do I have? It's until the end of the top of the hour, right? I want to make sure.
I think we can go an hour. Absolutely, the ball's in your court on that.
Okay, great. Thanks very much. So, hi everyone. It's a real pleasure to be here. Thanks, Graham, for inviting me. So what I'm going to talk about, this is actually a talk that was given at a recent Informs Analytics conference. And the title, as you can see, is Leveraging Large Language Models in Analytics Practice, Opportunities, Challenges, and Best Practices. And I'll get into, in a minute, I'll give some context and background about this work and why we did it. I just want to say that this is what I'm presenting here is the result of a working group that was an Informs working group that was set up, which I led, and it was led by the Informs Practice Section Board, of which I'm a member. And here at the bottom, you can see all the many people participating in this work group. So what's the context? What's the background here, right? So there are many people on the call, and I guess everyone has heard of ChatGPT and other large language models. And what we're seeing more and more is that large language models such as ChatGPT may significantly impact many professions, including knowledge workers or high-end or very skilled knowledge workers. And this is just one reference that this is a study, a very interesting study carried out by the Harvard Business School together with Boston Consultings, and you can see the link here. And so what they did, they actually took a group of consultants, and they gave them tasks. They asked them to design a business plan, basically for a virtual company. And they designed the task so that it was the type of task they usually did as part of their day-to-day job. And then what they did, they divide the consultants into some consultants, they gave them access to ChatGPT and some instruction and asked them to use that as part of their job, as part of carrying out their work. And the other consultants, they say, okay, do what you usually do. And they also try to do a very good job of having the same diverse set of skills across the two groups. So try to really have a very similar set of two groups. And what they got some very interesting results. So the consultants who used the large language models, they completed significantly more tasks on average. They did each task significantly more quickly in 3/4 of the time. And in addition, they produced 40% higher quality results. So it's not just that they did quicker, they also did better. And they also found, not surprisingly, that consultants who initially were scored the worst improved the most by 43%. So all consultants improved, both the both the highly skilled, experienced consultants and say more the newcomers. But the newcomers, or the ones with less skills, they improved by the most. But the picture is not all roses, because they then did another thing, which is why they call it, why the paper title is The Jagged Frontier, is because they say it's very unclear what tasks the AI is good for and what tasks it isn't good for. So what they did, they went and very carefully designed a task for which they knew that the large language model did not do a good job at. And then they asked the same the same two groups to carry out that task. And what they found is that actually the group that used the large language model did performed less well. They actually did worse than the group who did not use large language models, which show that. So basically, if we were to summarize, what this shows is that yes, large language models can potentially have tremendous benefits in terms of efficiency and quality, but they can also have downsides, because there's a tendency, especially after people who've used it gotten good results, there's a tendency to overly rely on the output of large language models, and not check it as carefully as it should be checked, which was the explanation that they found for why, for the second result, which was the poorer performance for this second type of task. So basically, the use of LLMs has benefits, but also has issues and risks. So given this, what we wanted to do is ask the question, what are the implications for the practice of analytics? We are in the Informs Practice board, we're trying to focus and help analytics apply advanced analytics and math to solving problems. So what are the implications of the existence of these new large language models for practice? And what we wanted to do in this work is the following. We wanted to make an analytics practitioner aware of the technology and potential value, because we wanted to understand if there is value, and if there is, let people or showcase or make people aware and try it out. Maybe it can help them do a much better job, much quicker job, much more efficient job. Suggest some possible best practices, but also very importantly, make everyone, if people who do decide, if analytics practitioners do decide to use these tools as part of the work, they should be aware of potential issues of its usage, including ethical and legal considerations, and of course, following this, provide guidelines for ensuring the ethical use of the technology. So what we so how did we go about it? We didn't just want to do like a very theoretical exercise. We wanted to really understand and give a concrete example. So what we did the following. We chose a use case. We chose a concrete use case, which was actually implemented by a member of the group, by Professor Dick Den Hertog from the University of Amsterdam. This was implemented in the traditional case without any large language models. So we knew, what the problem is. We knew what how long it took to implement, what the upsides and the downsides were, and we wanted to use ChatGPT-4 to walk. We used the ChatGPT-4 to walk through the very same use case with the entire implementation lifecycle, and now using a process known as the Informs Job Task Analysis, which I'll introduce in a minute. But we wanted to take it through the entire life cycle of creating an analytics application for this use case. Additional members of the team were Professor Leo Bucio from the University of Washington, who's both an optimization expert researcher, and he's the one who has had the most experience with LLM usage. So we wanted to make sure that we're using it correctly. We had also Dr. Arnie Greenland, who's an Informs fellow and an expert in the methodology that we used. We wanted to make sure that we did everything right. And as I mentioned, we had Professor Dick Den Hertog, who was not only led the team who implemented the use case initially for the client, but the two-time Edelman Award winner. So he's very experienced in applying analytics with very good results. Now, so what we did then, given this use case, given ChatGPT, is we walked through this process. This process is comprised of a set of steps, which I'll introduce in a minute. And we walked through the use case, but for each step, we sort of started the conversation with ChatGPT from scratch, because we were concerned about the issue of not being able to handle long context. So we sort of summarized the results of the previous conversation as an input for the beginning of the next conversation. That's the way we carried it out, and then went through each step. And then after we did this walkthrough and saw what we got, we asked for feedback both from Dr. Greenland, and who was an expert, as I mentioned, in the methodology, and Professor Dan Hertog, who was the expert on the use case.
Segev, just to clarify that point about the separate conversation, did you just restart the browser each time
Well,
your domain?
Well, we didn't restart the browser, but in ChatGPT has an option of like starting a new conversation. So you press we pressed a new conversation button and started from scratch. Now I know that, so we did it quite several months ago. We know now that ChatGPT has a new feature where it can also remember history across conversations, but you can ask it to forget. But at that time, that was not the case. That time, every time you started a new conversation, it was supposed to have an empty context.
Cool, thanks.
Okay. So so before we get into some of the work and the results, just a brief outline of the methodology used. So this is the job task analysis is actually a methodology, as written here, a framework that provides data scientists and analysts with an overview of the analytics process to ensure data-driven outcomes. It actually outlines the steps, knowledge, and skills that need to be carried out in order to successfully implement an analytics application. So you can see that it begins with business problem framing, or understanding what the business problem is, or because the modeler needs to understand it, framing this as an analytic problem, understanding the data, the relevant data, deciding what the appropriate analytic methodology is to solve it, building the models, and finally deploying the solution. Of course, doing this in it's not only the initial deployment, but also the model lifecycle management. So we follow this process, and I'm not going to go over in detail what appears in the slide, but you can see that each it's called domains. Each domain has a set of steps that you need to walk through in order to successfully implement it. So that's the methodology. And what we did, actually, we went through each of these steps in each conversation. So to clarify the comment earlier about the separate conversation, so each domain, we had a separate conversation, and in each domain, we actually had a conversation following the steps. So we first began with identifying initial problem statement. Then following that, we wanted to identify the stakeholders, and I'll show this in a minute, and so on and so forth. And this is what we did. Now, in this presentation, of course, I'm not going to show everything that we did, but I'm going to show some of the highlights.
So Segev, this JTA is part of the CAP credential, right, through Inform?
Yes, exactly.
Okay. And I mean, it seems reasonable that this would be a great template across pretty much any analytics project, right?
That's the goal. That's exactly its purpose, to make sure to give a template to sort of increase the probability of the analytics project being successful, right? Because we all know there are many challenges in having a successful analytics project. And actually, that's a very good point, Graham. Thanks for the question, because a lot of the challenges are associated with soft skills. And soft skills are something that many practitioners put less of an emphasis on. I mean, all practitioners are very good at modeling and understanding analytics and so on. Some are less good at soft skills, understanding constraints, business domains. For example, it could be an issue of not understanding missing a very important stakeholder that's vital for the success of the project, and just not addressing the needs or limitations of that particular stakeholder, right? So this template is also intended to cover the soft skills required for the successful analytics projects, not just the technical skills of modeling and optimization and so on. Actually, that's I'll come back to this when we discuss or see some of the benefits or outcomes.
Just a sidebar on this one. I know that you know the credential has had varied success, and it's being rethought a little bit. Do you see reference to this JTA structure in industry projects, or is this something that's kind of dialogue that's sort of mostly limited to the credential?
I think currently it's mostly focused on the credential, but this is based on methodologies that do exist that have been implemented in practice. I don't remember what the name escapes me right now, but yeah, I talked to Dr. Greenland, who was part of this, and he's a very experienced analytics practitioner, and there are methodologies on which this is based, right? So that are being used, but so that's I understand the current situation.
Thanks.
Okay, so just the final step before I start showing what the results of the interaction with ChatGPT, and that's give an overview of what's the use case that we wanted to implement, right? So the use case, this was for a company called Mobian Global. Basically, they wanted to identify optimal locations for bike rental hubs in Amsterdam. That was the goal of the project. They want to rent bikes, and they want to understand what the model is that people drive into parking lots, park their cars, and adjacent to the parking lot there is a stand where people can rent bikes, and so they can leave their car in the parking lots and take the bikes, and so and then they have the bikes with them throughout their working day, and then come back, return the bikes, and get back in their car and drive. So, and what we wanted to do, maximize the goals or the objectives was to maximize the number of users of the hubs and minimize the number of kilometers driven in the city. That is, sustainability was a very important goal of this project. And the targeted users, because of this very special case of being cars parked and bikes, are tourists, of course, but also commuters living outside Amsterdam and working in Amsterdam. This was not intended for anyone else living in it was not intended actually for anyone living in Amsterdam, but just people coming from outside Amsterdam into Amsterdam. That's the goal of this project. Now, and I'll return to this point in a minute. So now think about, okay, so we have this use case, we have this methodology, we have to come to the first meeting with the client. So the first thing that we began, this is actually even before the methodology, is we wanted to understand or wanted to, if an LLM, a large language model, can have any usefulness even before coming into the discussing with the client. We found it always very effective when applying analytics to understand the client, understand their goals, understand sort of their core set of values and identity, and so on. So we went to ChatGPT, and ChatGPT also has access to the web. And so we asked, we want to talk to this company, can you take a look at their website and provide me a brief summary? What are the core objectives and values? What would be important for them for optimizing their bike hubs? And then ChatGPT went to the website, summarized, and talked about, as you can see, simplifying urban transportation, reducing congestion, promoting sustainable mobility solutions. Maybe I'll just use a laser pointer. So promoting sustainable mobility solutions. And as you can see, it says very explicitly that values likely include innovation, sustainability, customer convenience, and efficiency. And this is very important because coming to the client, it's important to understand that the core set of values is also about sustainability and not just about profitability, which here is inefficiency. Then the next step is, okay, so now we think about a scenario, we come to the client, we get this description of, and I've shortened it so to fit on the slide, but we get this very long description and very sort of high level description of the goals and objectives. This is like, what do you want to do? So this may be a summary of a meeting. This may be a document that we get from them at the end of the meeting. So we give this long description as input to ChatGPT. And then at the end, we asked, we added this prompt, could you please identify initial problem statements and desired outcomes? And so as you can see, ChatGPT did quite a good job of summarizing the information, throwing out a lot or ignoring a lot of the history, which was probably irrelevant for this, and then gave very detailed list of possible desired outcomes. Data-driven location analysis, demand forecasting model, local compliance and partnership, and so on. Then the next step, we say, okay, as a follow-on conversation, identify all stakeholders and their perspectives. And here we got, again, a very comprehensive list, many of which we would not have considered, or we may not have considered, definitely not upfront, like local government and city planners. As you can see, it picked up on the commuters and tourists as the primary users and secondary users. It did not, however, specify that commuters were only people living outside Amsterdam. And actually, this was not clear to me either when I looked at this until I talked to Professor Dan Hertog. So this is a mistake that's sort of also possible to make for a human, but it's a very important point to pick up on, that commuters here are only people living outside Amsterdam. This is not intended for commuters within Amsterdam. It explicitly says local residents, which is not the case. Sorry, local residents, it doesn't mean necessarily that it doesn't say them as users, it says there are people who would be affected by the solution. So you can see it's really a very comprehensive list of possible stakeholders, many of which environmental groups and advocates. If we talk about sustainability, very important, regulatory bodies, so very important or very comprehensive list of stakeholders. However, what we didn't like about this response is that it didn't focus enough on the internal stakeholders within Mobient. It only talked at a very high level about the Mobient management and operational team. So we asked the follow-on question, can you elaborate on the various stakeholders inside Mobient? And then we got, again, a very comprehensive list of stakeholders within Mobient, executive team, operational management, and I especially like to emphasize the IT and technology team, because going into a client and based on my experience, I know that in many cases, not only doesn't the practitioner consider the IT and technology team as an important team to consider, but even the client often doesn't think of them. And then what happens is that you get, if you don't involve them up front, you get to the point where you need to deploy the solution. And then it turns out that you can't deploy it because the IT team can't connect your solution to the data, or even when developing the solution, you need data from the IT team. So the IT team, the IT and technology team typically needs to be brought in very early on in the client conversation. So this is very important that ChatGPT picked up and emphasize the IT and technology team as an important stakeholder. Of course, there could be a lot of stakeholders which may be relevant, but which are not really relevant in this specific situation, right? This is important point. Then the
Segev,
next question,
how
yeah,
many folks do Mobian have on staff currently, or at the time of the project?
I don't know. That's a question actually I didn't ask. I'm sorry. Why do you ask? Why did you?
I was just
Yes.
looking at the relatively elaborate breakout of stakeholders. I just wondered, if you had a sense of how large the
Ah,
operation
okay.
is. I mean, they're only
Yeah,
doing 200 bikes or something, right? 200-300 bikes, so it can't be very large.
yeah, I don't know. I really don't. Then we talked about, then we asked, can the problem be effectively addressed by analytics, and how? And you can see again a very comprehensive set of analytics: geospatial analytics, demand forecasting, customer behavior analysis, traffic. And so, for example, geospatial analysis is something that Professor Hertog really liked that ChatGPT picked up on, because it's something that, again, it's not something that you may typically think of as a practitioner, but here was very important. However, what we saw here again is that optimization was not explicitly mentioned. And of course, some, again, may not be relevant for this use case. Socioeconomic data analysis may or may not be relevant for this use case. You can see that ChatGPT like throws a bunch of ideas out. It's very good at, or does like brainstorming. No idea is a bad idea. So it gets a lot of good information, but also gets information that the practitioner will need to decide whether it's relevant here or not, right? But so regarding optimization, as I mentioned, it didn't pick up on optimization, or I don't know if I mentioned, but what we saw here, it almost forgot. It didn't say anything about optimization, even though the goal was optimizing bike hubs. It didn't say anything about optimization, so we had to ask it explicitly again about optimization as an analytical tool. Would it be relevant? And then it says yes, absolutely, and then gave the optimization, location optimization, which is again the primary one. Resource allocation. The other ones are probably less relevant, route optimization, and so on. So, so it picked up on the most relevant, but again, through a lot of other ideas, which probably, some of which are less relevant here. So if we were to summarize this step, so it provided indeed a comprehensive and valuable set of insights, such as comprehensive list of stakeholders, which I mentioned, including IT and users, comprehensive list analytics. And also we felt it was, or Professor Dan Hertog felt was very effective towards driving the core of the problem, summarizing initial input and actually coming up with a concise description of what the problem was that we needed to address. However, there's still a lot of work here that still has to be done by the practitioner. For example, understanding when additional details are required and asking follow-on questions, such as refining the stakeholder definition or asking the follow-on question on optimization. Understanding what is and isn't relevant. Exactly as you said, Graham, it could be that the team is so small that a lot of the teams mentioned that don't even exist, right? Or are very small, and so not really relevant in terms of internal stakeholders. And ultimately, this is something that the practitioner needs to take the inputs of, compose it, compile it with their knowledge and skills, and come back to the business user and discuss this with them. For example, it's very important that it be understood by the analytics practitioner that commuters should only refer to people living outside Amsterdam, even though this is not something that was explicitly mentioned by ChatGPT. Moving on to any questions before I move on to the next step?
Any questions, folks? You can chat them in as well if you like here on the call.
Okay, so the next step is analytic problem framing. So we began. This was the the summary that we gave. This sort of the summary of the previous step. So we gave this as an input. We asked ChatGPT to have this analytics problem framing for discussion with the client as a final step. This is what GPT gave us. So so this is sort of a summary. This shows another use case of ChatGPT, of sort of taking everything, summarizing it, and sort of consolidating this, or a large language model, and consolidating this into a summary that you can take and present to the client, and again, initiate discussion with the client, taking all of the previous conversations, consolidating it, and so on. Here we come to a point where there's another thing that I'd like to emphasize. So again, we went through the list of questions for this domain of analytics problem framing, which I mentioned. We took the summary of the previous conversation, and the result of this, and the outcome of this step was what ChatGPT. We asked ChatGPT to summarize at the end, so something we could show to the client as analytics problem framing. This is what we got. But again, here there was something very important that the analytics practitioner needs to weigh on. So because remember, the goal is to serve people coming outside Amsterdam, coming from outside Amsterdam, and working or visiting Amsterdam. So you could think that what you'd need to do, you'd need to create models for every village or town or city outside Amsterdam from which people travel into Amsterdam. You need to have some demand forecasting model if you want to forecast the demand, which is of course very complex and very difficult to do. So what was actually done, and this was something again thought about by Professor Dan Hertog in their team, is that actually what we need to do is create models of demand of people coming in through junctions into the city. So if you look at the map of the city of Amsterdam, you can see the road junctions coming in, the crossing of these gray lines. And basically what was actually needed was just models of people traveling, or how many people on each day come in from each junction into Amsterdam, which is of course a much simpler model to create. This is not something that the large language model thought of in our interactions. This is something that we actually even tried asking some questions about how you do this modeling, how you do that. It didn't come up with this idea. So again, this is a place where the analytics practitioner has to weigh in with their experience and ingenuity in order for the engagement, for the application to be successful.
So give those intersections, were you able to get traffic volumes from, like the city or something like that? Were they available, or did you have to?
They were available. I don't recall exactly what the source was, but yes, they were available.
Cool.
So if we were to summarize this step, and so it again, I didn't show that, but it provided an important comprehensive set of assumptions, making it less likely for practitioner to miss the key assumptions. And as I said, we showed a new use case of like summarization, which is like a classical use case for large language model, summarization and consolidation to sort of summarize everything and create a good, concise summary which can be used as a baseline for discussion with the client. It's not necessarily you take the summary as is and show it to the client, but it's something that you as a practitioner can take and build on to take to the client. Again, there's still a very important role for the analytics practitioner, ensuring that no assumptions have been missed, and as I discussed, this need to efficiently model the demand of commuters. Moving on to the next steps, we now about data needs and sources. So we asked, so again, we took the summary, the analytics summary that I showed from the previous discussion, gave it as an input and say, okay, now please identify and prioritize data needs and sources. So it gave this a very comprehensive list of data, prioritized it. And here we know that a large part of any analytics project is data cleansing and filling in missing values, removing outliers, and so on. So for one of these types of data, we asked ChatGPT to generate code for showing how this would be done. So code was generated. Again, this could be, we haven't actually run or tested this code. This was but it's something that we know has to be checked, but at least it gives a baseline. It gives an initial place to start for any practitioner who's less experienced with data analysis and consolidation. So again, to quickly summarize for this step, the example of values: provide comprehensive list of relevant data sources, making it less likely important data sources be missed, potentially simplifying, accelerating data cleaning and transformation by providing initial code for this task. An analytics practitioner really has to weigh in to understand which data is relevant, and to your question, Graham, which data actually exists, right? Because of course, historical usage data, because these were new bike settings, did not exist. So either there could be a discussion of how to estimate this historical data, or how to estimate usage data, but of course this data did not exist, and validate the code for data transformation and complete it. Going to the next step of methodology and approach framing. So we asked, what are the available? This is now the next domain, again summarizing all the discussions on the previous domain as input, asking what are the available problem solving methodologies and approaches: operations research techniques, optimization, machine learning and predictive analytics, geospatial analysis. Again, this was Professor Dan Hertog was very happy that this was picked up on, because it was very important as that part of the work, and not necessarily something a practitioner would think about initially. So I'm shortening each step because I don't want to repeat the types of things that I've already shown, a type of value that I've already shown. This was, of course, a very long conversation. So if we were to summarize this step, again, we saw the value here that we saw is the example of values, providing the comprehensive list of analytics techniques, including ones which with the practitioner may be less familiar, and so hopefully this will make it most likely to use the most appropriate technique. As we all know, it's very hard to always keep up with the latest techniques for each types of use case. So at least this gives the starting point of maybe techniques that would be relevant here, that at least I as a practitioner can then go out to the web and check, learn more about it, and figure out whether it's relevant here or not. But ultimately, the selection of the set of techniques is what has to be decided upon by the analytics practitioner. The next step was, okay, now I've sort of decided which techniques I want to use. So I want to use optimization. This is a given. There are other techniques here that were relevant also, but let's focus on the optimization piece. So the next step, okay, let's build the models. So we can go to the large language model and ask, okay, can you help us create the model for this? So we gave a very detailed description. At this point, we had a very detailed description of the actual problem. We gave it to, and you can see there are many parameters here: the minimum distance from hub to the point of interest. So basically what happens, the way that this is modeled is that, as I mentioned, people come into junctions. They want to arrive at points of interest, whether it be a workplace or a museum or something like that, and they have to go through a bike hub. So we asked ChatGPT to create a model, an optimization model for us, taking all this information into account. So ChatGPT understood or mapped the variables. You can see that it has the xi. So these are binary variables, and there's a yij variable that says equals y if commuters entering the city at junction J use the hub at location I to reach their point of interest. And and it summarized the parameters and then created this model. Now, this model, given the set of parameters, is actually correct. There's and another nice thing about it is that it's a mixed integer model. It's not a nonlinear model, so it can be solved, using the commercial or solvers that are available out there quite effectively. But what happened here is that underlying this model was an assumption that all people entering from a specific junction would use the same hub, whereas the actual hub should actually depend on the point of interest in which they want to get to. So you should have a separate variable for each junction, each hub, and each point of interest. So then we asked ChatGPT, okay, please reformulate the problem, accounting for the fact that people entering from the same junction may use different hubs, and here now and ChatGPT corrected the model, and now, as you can see, there's a variable for each junction, hub, and point of interest, and the objective function is updated accordingly. So again, this is a very important place for the analytics practitioner to weigh in and not overly rely on the model. The model is even correct in the sense that it will run, it will solve, and to give you a solution, but the solution will not be good in the sense that it will introduce the underlying assumption or constraint that didn't exist in the original problem framing of all people entering a hub going to the same, all people entering the same junction using the same hub. I'm going to, in the interest of time, I'm going to skip some of the slides here because I do want to leave time for questions and answers. And I do want to get to the summary, which is the important part. We did the rest of the steps. So let's now summarize. So as you may recall, at the beginning when I introduced the use case that was done by the Harvard Business School, I talked about two things. I talked about improving the quality and improving efficiency or shortening the time. So let's see why we think that for analytics practitioners, a usage of a large language model could improve the quality. Because, and these are the lists. So, in terms of improving quality, it provides a comprehensive list of domain and problem-specific considerations across the entire lifecycle, as we discussed: stakeholders, metrics, data, relevant analytics, validation. It would be extremely useful for less experienced practitioners, but also useful for experienced practitioners less familiar with a specific domain or relevant analytics skills techniques. New analytics techniques like geospatial analysis. I've been a practitioner, I've been in this field for decades, and I haven't actually done any significant geospatial analysis, for example. And I said, figuring out who the right stakeholders are is very important for ensuring the success of the project and addressing their needs. It's also very useful to better understand specific clients or new domains. It's also very useful for additional viewpoint, making sure nothing has missed out. Often there's the danger of experienced practitioners coming in and sort of making the mistake of thinking this use case is very similar to this other use case, where actually there are very significant differences. So just running it through a large language model, having this sort of additional voice or having this additional checklist can be very useful, or additional opinion, and can be very helpful in driving, accelerating. You can feed in what the client gives you, try to understand it better, ask questions, get viewpoints, and so on. So it can make it much more likely that all important considerations will be taken into account. So thereby improving the quality of the solution, potentially improving the quality of solution and probability of acceptance. So this in terms of improving solution quality. In terms of acceleration, so we saw how it could be very useful for creating the initial model or code, or we used it also to generate documentation or to get, so I didn't show it, but one of the steps is, okay, now that you have the system, please create an outline for a user manual. Please create an outline for, a support manual, things like that, which are very important for the life cycle of a project, and could also help greatly for, if you've never done geospatial analysis, haven't used a specific library in Python or anything like that, you can use it and implement it. And as I initially mentioned, significantly accelerate the practitioner's understanding of the problem by helping to drive to the core, like summarizing and understand, okay, what's at the gist of what the client really wants to do? What do they need? What should analytics address? However, another thing that we saw is that we saw an emphasis of how important analytics practitioner is in the experiment, because we saw, for example, those examples where we needed the experience to drive the interaction with a large language model. We need the experience of the practitioner to understand that we need to understand better, for example, the internal stakeholders. We need to understand that optimization was not considered by the large language model and ask. We need to understand which analytics techniques are important here, focus. So as you saw, the answers, at least the ones that we got, and of course there are ways to get the large language model to give more focused answers, but we asked purposely very broad answers. So when you do that, you need to help focus what's really important or what's really relevant for this use case. And you still need to truly understand the problem, understand that users here are commuters only, referring to people living outside Amsterdam, understanding how how things could be modeled using the junctions and not having to model everywhere traffic coming anywhere from the Netherlands. These are things that picking up on the fact that you shouldn't assume that everyone, this goes to the first point here, models suitable for the business problem. So it's not, as I said, it's not that the model was incorrect. The model was correct. It would have run, it would have given you a solution, but it introduced an additional constraint which was not present in the original business problem, which is that all people coming in from a junction should use the same hub. This may have been a reasonable assumption, but it was not incorrect in this case. So really the practitioner needs to understand what are the real core assumptions and make sure no erroneous assumptions are available or made by the model, understanding what could be ignored, which of the comprehensive list of items can be ignored. I mentioned this, ensure that no items being missed or neglected. There's a very real risk here. This goes to the over-reliance. You're getting this great, this huge list of suggestions. It's very easy to assume that everything has been covered. You shouldn't assume that. It doesn't mean that everything has been covered. It's simply another checklist that you can add to your list. There's we'll need, as we go along and as large language models become, people more and more use large language models, need to understand what's the correct point in time. Should we first do some initial brainstorming by ourselves and then involve the large language model to give additional ideas, or will that bias the way we ask the questions? Should we do that? So there are many questions here, but ultimately it's up to the analytics practitioner and validate the correctness and appropriateness, exactly as you said, Graham. In terms of stakeholders, maybe many are not relevant here because the company is too small, right? Analytical techniques, it mentioned simulation, multi-criteria decision-making, none of which were relevant in this specific cases. Data types may not be relevant, and so on. And so perhaps the most important thing that I want to emphasize, and this is why this slide is in bold, even when using large language models, the analytics practitioner still maintains the overall responsibility and ownership for the analytical solution. Something goes wrong, you can't, a mistake was made, something was missed, this is the responsibility of the analytics practitioner, exactly as if the project is a huge success. This is because of the presence of the analytical practitioner, and not just because large language model was involved. Large language model should just be seen as another tool in the toolbox, which must be correctly and responsibly used. And so now let me spend a couple of minutes, but I can't stress this slide enough. This is a viewpoint, but we feel that this is very, very important. This is the current viewpoint in which this should be the usage of large language models or generative AI in general should be taken just as another tool, and the ultimate responsibility lies with the user. Now, as we know, LLMs, now going back to the issues and risks, and because we say, okay, responsibility, what you should be, because it's the analytics practitioner responsibility, what should the analytics practitioner be aware of? The analytics practitioner needs to be very aware of these issues with large language models. So first of all, it's a machine learning model. It's heavily dependent on the training data. Right, so of course I mentioned we used here ChatGPT, but there are many models out there, some proprietary, some open source, some more focused, some less focused. So you should really think about what the training data is and how good it is for what you want to do. Now we all know that generative AI is prone to generating convincing, very highly convincing, but erroneous content, hallucination. So you could even think, some people even refer to that constraint that was introduced by the first model as an hallucination, because you could think about it as the large language model hallucinated or added a constraint that wasn't really present in the data. You need to carefully check when you use a large language model. You need to carefully if you use a proprietary model, or you need to check what the vendor can do with the data, because if you often in client projects there's private data involved, there's highly confidential data. You don't want that to be used for training models, for training the next version of the model. There are IP issues, as we know. This is an open, as many know, it's an open contested questions. So data was used, often internet data was used to train models, because generative AI and large language models need a lot of data. So who owns the parameters of the trained models? Is it the people providing the data? And who owns and is the data allowed? And when you generate new content like code, who owns the code? Are you perhaps even plagiarizing existing code that was used to train the data? So you need to be aware of these IP issues. And of course, large language models have very significant computational costs. So you need to factor this in, either into when you do the pricing, when you do the effort, when the cost estimation. If you deploy a solution using a large language model, you need to be aware of this. So to summarize the best practices and taking all the issues that I mentioned into account, again, stressing again this overall ownership or responsibility for the analytics solution, treating the LLM as an additional tool, and all pre-existing ethical considerations or guidelines for providing an analytics solution continue to apply. This doesn't loosen or make any of these existing restrictions vanish. You should never overly trust the large language model output. Critical thinking is a vital skill, and validation is a vital skill when using large language model. This is really perhaps one of the things that society will need to emphasize in this era of generative AI: critical thinking and validating the output of a model, not relying on anything output by the model, not taking its word, but making sure it's grounded in some sort of a reliable source or information. You should, if you do want to use large language models, you need to become skilled how to use effective prompting and summarization. There's a lot of work out there, but it's still a combination of both an art and a science. As I mentioned, be aware of the IP issues, be careful of what data you upload to the large language model. You may even want to make sure if you use a large language, you may want to notify or let the client know that you're using a large language model and get their explicit permission to upload their data to the model. But this does not mean, again, that you're removing the responsibility of the usage of the LLM, of the overall responsibility, but at least you're getting permission for uploading the data, account for the computational resources. And finally, again, LLMs do not fully replace human creativity. They can be a great accelerator. They can be great brainstorming partners, but ultimately they may miss some stuff. They may, completely bring things that are irrelevant, and definitely critical thinking. Mention perhaps the most important skill we'll have to learn. So to summarize, demonstrated how large language models could be used throughout the life cycle. Well, I didn't take through that, but this is what we did. We described the issues, and we emphasized or showed how important the analytics practitioner is, and how and perhaps provide some guidelines for interaction, while while hopefully obtaining the value of that can be afforded by large language models or other types of generative AI. So with that, I have a couple of minutes for questions. I guess if we go the hour, Graham.
Sure, thanks. Questions, folks?
Hi, I have a question. It's a very informative talk, Segev. Thank you so much. And I think there is a, can you hear me?
Yes, yes.
Yeah, so I think there is another kind of study carried out by the McKinsey company, and they one conclusion they find out from the study is saying that if the large language model tools are used by bad programmers, it will simply produce more bad code faster. So I think how to evaluate the efficiency of our usage of large language models, I think we can do a lot of things here. So this is definitely an interesting one. Since you mentioned about the hallucination, have you experienced like significant hallucination issues in your project here?
So with this particular one, so let me maybe also address the first. So I'll answer the question. I'll address the first comment that you made. We didn't experience significant hallucination. I think the closest we came was what I mentioned, is that it picked up, it sort of introduced or hallucinated a constraint that was irrelevant, right? And it did so in a very subtle way, just by defining the decision variable in a different way. It didn't add a new formula and says this is a constraint which you could look at, but it just introduced decision variable. So that's the closest we came to hallucination. Other than that, we didn't. But what we did run across, and this is also important, which doesn't appear in the slide, is that ChatGPT changes, the versions change, and so we saw often that sometimes the behavior even deteriorates. As if you ask a newer version of ChatGPT a question, sometimes you get poorer responses than when you got with older version. Regarding your first question, yes, I absolutely agree that if bad programmers will use, ChatGPT to generate code, just more bad code will be. This is exactly why the experience and expertise of the practitioner should be is vital here, and this is also exactly why I think we also need to understand what this means for education, right? How do we now educate people, programmers, analytics practitioners, whatever, to make sure that they still have their core skills, their core knowledge that they need in the presence of large language models.
Thank you.
Questions, folks? So Segev, a lot of thoughts pop up during your talk. I think one is that you came in as a team of humans with that commitment to what a commuter looks like, right? Somebody who lives outside, and instead of being pretty hard on here's the line, and if you live that side of the line, you're a commuter, and if not, then you're a local resident. And I think it's interesting how a tool like this could actually soften some of the human commitments, maybe over commitments, right? A second thought was that, you mentioned these outside stakeholders, and you sort of left us at the point where you generated this mixed integer linear program, which, presumably we could go back and ask chat to generate some Gurobi code and have that execute. And, this idea that we can use Python as the back end of all of our workflows and use sort of chat as the front end opens up this prospect of sort of doing something that we have not yet done in our classes here, which is to sort of, maybe go and run the code, generates, a map showing these locations, and then actually push that imagery at our end users for comments, right? Because ultimately they're going to go look at them. Graham, I don't think so. I don't like that. I like this one more than that. And so that sort of the view of how we could take these workflows that we use as analysts, we're doing hackathons here, machine learning hackathons, where we basically use chat for code, fix code breaks, but not so much for, what's missing in my notebook. So those creative elements. So I think we're sort of, it's up to us to train ourselves to be new users of LLMs. What are your thoughts about these ideas that I've just talked about?
So absolutely. So regarding your first comment about softening, yeah, definitely, that's exactly what I meant about, commuters, about, not making the large language model helping you ensure not that you don't sort of bias yourself coming into the problem. And sort of suggesting, and I absolutely agree. It could be that the right way to go about it, as I said, this project was not with the client, was not implemented with large language model. But if it were, this is an exercise we did after the fact. But if it were, yes, definitely a good way would probably to go to have this discussion, understand, are really commuters just, should it just be people coming from outside the city? I absolutely agree. I agree with you. Regarding your second point, I also absolutely agree. I actually think there actually is a lot of work in this area of like using this this end-to-end. We actually some colleagues who participate in this work group and myself and several others actually published sort of a vision paper of exactly what we call a decision optimization co-pilot, of having the system interacting with the user and driving it all the way to the I can send anyone who's interested the link, interacting all the way to, to actually generating the code. And actually, we did generate the code also in this exercise. Just so I didn't show it here because I showed the code generation for the data. So I didn't want to repeat it, but we still found a lot of gaps. And yes, I think so. Actually, a very interesting pattern that we see now being used is having sort of multiple instances of the same large language model with different prompts. So, for example, one large language model is getting an input saying, "Okay, you generate the problem," but then another large language model is having, "Okay, look, this is the problem description. This is the code generated. What are there any errors in this code?" And actually, what was found is that running this loop several times was actually much more successful at generating a working optimization code that actually, or correct optimization models. So that's to the end-to-end. And yes, definitely I think what you mentioned is like taking having a system where the business user interacts with a large language model and then having the solution presented at the end and then giving feedback on the solution and then sort of rolling it all the way back. I think that's like the holy grail of where we would like to get to with this type of application, right?
We still keep the human in the loop. And I think that's it's like a vision for the new role of the human, right? Taking us away from some of the combinatorial drudge stuff that we're not all that good at, and trying to actually be creative. And,
and making the decisions, right? I mean, we need to be the ones making it. We need to be the ones with the hands on the wheel. It's not that.
Yep.
Yeah.
I think this is go ahead, Minghong.
Yeah, so I actually want to ask this question for all of our analytics students, right? As some of the students saying that they are worried that the job will be replaced by AI, but definitely the case here show that we have something new to do, right? Handle the real creativity and also the true understanding of the problem and your clients. So based on that, Segev, what is your suggestion to our analytics students that what type of a skill set they want to focus on, given that we have large language models now? And maybe other skill set that will become less relevant here.
Yes, so I can address that at several levels. First, I think that ultimately there'll always be sort of the core business problems. Like today, like there's these companies which even have their own analytics team that, like UPS or FedEx or Amazon or that handle that create the models for the core business processes. What differentiates them, whether it's making effective deliveries or effective supply chain in the case of Amazon or others. So for that, I think for that, it's very hard to foresee a future where anyone other than human modelers will do that. And as currently today, where we are now, yes, the analytics practitioner has a vital role to play, as I said, in critical thinking, in overriding. And for that, they need to have the same set of skills. They need to have the same set of deep analytical skills and understanding in order to have this creativity. They also need to have an understanding of the soft skills required, right? As I said, understand the importance of different stakeholders, understand that it's important not to leave anyone else. Here, but here we feel that actually the usage of large language models can help educate them how, about stakeholders, about others. It will be much easier for them to pick up on the soft skills given these advantages of large language models. Large language models could also help them learn about new analytical techniques but understanding and so on but I think it's very important whether or not what we're seeing more and more is companies now are really looking for generative AI skills. And so I think it's important for definitely for analytics students, AI students to learn Gen AI skills, understand, the basic principles of generative AI, understand effective prompting, how to prompt, how to use it. I think that what will happen is that, this is my prediction, right? I don't know if it's true or not. I think that what will happen is that as generative AI sort of removes the drudgery from a lot of the existing work, people will become more and more focused on decision making, right? And so I think that when people or enterprise will become more and more focused on decision making, actually the analytics practitioners who have on the one hand a good sense of generative AI skills, but on the other hand a very good knowledge of operations research techniques, optimization, analytics, they'll really be differentiating themselves in the market. So this is what I'm trying to push, and this is what I'm trying to do for myself, is learn as much as I can about generative AI and see how I can combine that together with the operations research and sort of management science in order to sort of drive towards this sort of hopefully better world where we can now make better decisions in a much more widespread manner.
Thank you.
Any other questions, folks? Segev, I really appreciate your time here, and especially your patience at the start with the slowness on the audio, but some really great insights here, and really appreciate your work here today. Thank you so much.
Thank you very much, and thank you very much for inviting me. It was a pleasure to be here, and I wish you a great rest of the work conference or workshop.
Thank you much.
Thank you.
Goodbye.